Hello everyone, this video is about polynomial differentiation and chain rule. So in the MF19 you see this formula, differentiation f of x, x to the nth power, f prime of x, n times x to the power of n minus 1. So this is called the polynomial differentiation formula. When you differentiate x to the nth power, simply bring this n down, so you have n times, and the new power is the old power minus 1. So for example, originally x squared, after you differentiate, you get the derivative, the y prime, 2 down, so 2 times, the new power is 2 minus 1, which is 1, so you get 2x. Another example, x cubed, bring the 3 down, 3 times, the new power is 3 minus 1, which is 2. If the power is 1/2, bring it down 1/2 times, the new power is 1/2 minus 1, which is minus 1/2. If the power is minus 2, you bring it down minus 2 times, the new power is the old power minus 2 minus 1, minus 2 minus 1 is minus 3. So that's it. Now, when you have coefficients, you simply rewrite the coefficients. So for example, if you have 10x squared, just rewrite the 10. So you have 10 times the derivative of x squared is 2x, so 20x in the end. So if you have 1/3 x cubed, just rewrite the 1/3. When you differentiate this, you bring the power down 3 times x to the power of 3 minus 1, which is 2. 1/3 times 3 is 1. Minus 2, just rewrite the minus 2. You bring the power down minus 3 times and so on, so you get this. When you have addition and subtraction, we can differentiate separately. So for this x to the power of 6, we bring the power down. We have 6 times x to the power of 5, 7 times x to the power of 6. Same thing here, another example. Minus 3 times 2 is minus 6, so minus 6. The new power is, actually this is minus 4. I mean not minus 2, minus 3 minus 1 is minus 4, I mean. Alright. And 5 times minus 4 is minus 20, the new power is 4. And minus 1 times 2/3 is a minus 1/3. Minus 1/2 minus 1, that's minus 3/2. If it's a linear, which means it's just something times x, just erase the variable, and if it's a constant, it becomes 0. So for example, 7x. 7x is the same as 7 times x to the power of 1. If you differentiate this, you get 7 times, bring the power down 1 times x to the power of 0. Anything to the power of 0 is 1. So we have only 7 basically. Okay, so if it's something with x, like ax, we get a only. Same thing here, no matter how complicated the coefficient is, just rewrite the coefficient, just like erase the x. If we have a constant, for example, y equals 5, so just 5, there is no x. So this is the same as 5 times x to the power of 0. If we differentiate, we get 0 times x to the power of minus 1, but basically we have times 0. Anything multiplied by 0 is 0. So that's why if it's a constant, the derivative is 0. By the way, this is prime, y prime. And we have here, there is no x again, so the derivative, if there is no x, if it's a constant, the derivative is simply 0. And remember, in the laws of indices, roots means 1 over reciprocal power, and reciprocal means negative power. So for example, square root, reciprocal power, reciprocal means 1 over something, so 1 over 2. And if we have 1/2 times x to the power of minus 1/2, this means we have, this is after we differentiate, bring the power down, we have 1/2 times the new power is minus 1/2. You can simplify this, x to the power of negative, this is the same as 1 over x to the power of, and x to the power of 1/2, this means the square root, so we can also say this is the y prime. Reciprocal 1 over, this is the same as x to the power of negative 2. So the derivative is negative 2 times x to the power of negative 3, which is the same as 1 over x to the power of 3, so it's minus 2 over x cubed. So if we have reciprocal and root also, 1 over cube root, so 1 over x to the power of 1/3 for the cube root. For the 1 over something, we use negative power. The derivative is, we bring the power down, minus 1/3, the new power is minus 4/3, so it's 1 over x to the power of 4/3, so it's 1 over x to the power of 4 times 1/3, which is the cube root of x to the 4th, which is 1 over 3 times the cube root of x to the power of 4. So remember the loss of indices. And more notes, multiplication and division cannot be separated and differentiated individually. So if you think x cubed over x squared, oh, x cubed becomes 3x squared becomes 2x, this will be wrong. Or 1 over x squared, oh, we have 1 over x squared becomes 2x, this is also wrong. If it's a multiplication, oh, just do the 2x squared becomes 2x, x cubed becomes 3x squared, also wrong. We can only separate if it's an addition or multiplication. If it's an addition or subtraction. If it's a multiplication, we cannot separate the x squared becomes 2x and this parenthesis becomes 3 plus 12x squared. This will be wrong. So again, this is wrong. You cannot separate the differentiation for multiplications and divisions. The right way to differentiate a multiplication or division is by expanding or distributing or opening the parentheses, or by splitting the fraction. So for example, if it's a multiplication, just do the rainbow method. You just expand, open up the parentheses and distribute, and then differentiate. If it's a division, just split the fractions. So we have 2x over 4x cubed, 3x squared over 4x cubed, simplify, and then we can differentiate. And chain rule. So in theory, we have this concept dy dx is the same as dy du dx. So it's just kind of like multiplying fractions. Du cancel out, we have only dy dx. So for example, if we have y equals 3x plus 4x squared all to the 5th power, we use another letter, let u be the base 3x plus 4x squared. The du dx, we differentiate u with respect to x, so we differentiate this, we get 3 plus 8x. Now the y is now u to the power of 5. The dy du, we differentiate y with respect to u. So we bring the power down, 5 times u to the power of 4. The y prime, or the dy dx, is therefore dy du dx. The dy du is 5u to the power of 4. The du dx is 3 plus 8x. And we cannot use u for the final answer, we have to use x. So 5 times 3x plus 4x squared all to the power of 4 times 3 plus 8x. This is the final answer. So in practice, all we gotta do is to think of this as y equals x to the power of 5, in which we get 5x to the power of 4. So just 5 times the same thing inside the parentheses, exactly the same, to the power of 4. But we have to multiply by the derivative of the 3x plus 4x squared, which is 3 plus 8x. So just differentiate and we multiply by the derivative of whatever inside the parentheses. Right, that's it. I'll see you again next time.